C.R.O. Cathode ray oscilloscope. C.R.O. Cathode ray oscilloscope. Okay. C.R.O. Cathode ray oscilloscope. The cathode ray oscilloscope is an instrument which can record instantaneous value of rapidly varying voltages. Okay. It is used to observe various alternating current waveforms and put to other uses in radio engineering, television, and industries. It essentially consists of a cathode ray tube, C.R.T, and sweep circuit or time-based circuit, and third is synchronization circuit, and fourth is high and low voltage supplies, and fifth is horizontal and vertical amplifiers, which are discussed below. Okay. The cathode ray oscilloscope. The cathode ray oscilloscope. The cathode ray oscilloscope is an instrument which can record instantaneous values, which can record instantaneous value of rapidly varying voltage, rapidly varying voltage. Okay. Voltages. It is used to observe various alternating current. It is used to observe. It is used to observe various alternating current. Various alternating current waveforms and current waveforms and put to other uses and put to other uses in radio engineering, television and industries, television and industries. Okay. It essentially consists of first a cathode ray tube, C.R.T. Cathode ray tube consists of cathode ray tube, C.R.T. Second, a sweep circuit or time-based circuit. A sweep circuit or time-based circuit. Okay. Third, synchronization circuit. Synchronization circuit. Fourth, high and low voltage applies. applies. Fifth, horizontal and vertical amplifiers. Horizontal and vertical amplifiers. Horizontal and vertical. Horizontal and vertical amplifiers. Which are discussed below. Okay, which are discussed below. 1 minute. Which are discussed. How to discuss at each point. Then first is cathode ray tube. Cathode ray tube. Okay. First, cathode ray tube. The cathode ray tube is an evacuated tube of the shape. You can show the shape of cathode tube. Cathode ray tube. This is the cathode ray tube. Okay. This is the cathode ray tube. Cathode ray tube. Its main part are an electron emitter. Called the cathode or device to control the intensity called the grid. Accelerating and focusing electrodes A1, A2 and A3. A1, A2 and A3 is the accelerating and focusing electrodes known as anodes, deflecting plates vertical Y and X deflecting plate, and horizontal X1, X2, and screen which fluorescent when electron impinging on it. Okay. Then first is cathode ray tube. First heading, cathode ray tube. Okay. The cathode ray tube is an evacuated. The cathode ray tube is an evacuated of the shape you can show before. Its main part are electron emitter. Its main part are an electron emitter. Its main part are an electron emitter called the cathode. Electron called the cathode. Okay. Cathode K, or device to control the intensity called the grid. Or device to control the intensity. Intensity called the grid. And next is A1, A2, A3. A1, A2, A3 is accelerating and focusing electrodes. Accelerating and focusing. Accelerating and focusing electrodes known as anodes. Okay. Known as anodes. Okay. And deflecting plates vertical and Y1, Y2 vertical deflecting plates. Vertical deflecting plates, and x1, x2 horizontal deflecting plate. Okay, horizontal deflecting plates, horizontal deflecting plates. Okay, and screen which fluorescent, and screen which fluoresces when electrons impinging on it. Okay, first electron emitter, electron emitter. Okay, electron emitter, first electron emitter. Okay, electron emitter. The method of obtaining the electron is similar to that used in a harmonic valve. The cathode K is indirectly heated by passing a suitable current through the filament FF. Okay, the cathode K is indirectly heated by passing a suitable current through the filament FF, which is electrically insulated, but thermally connected to it. Okay, the cathode is oxide. Coated type with an material like MgO. Okay, and when heated gives out a copious supply of electrons. For details refers article of previous. Intensity control. Second, intensity control. Okay, intensity control. Okay, intensity control. Next, intensity control. Okay, intensity control. 1 minute. Intensity control. Intensity control. Intensity control. Okay, intensity control. The cathode is surrounded by a metal. The cathode is surrounded by a metal shield in the form of cylinder, with a hole at the end farther from the cathode. The cylinder is given a negative potential with respect to the cathode, so that the electrons are repelled from it, and any of excess electrons joins the axial shield or modulator. By varying the negative potential of the grid, the emission of electrons from the cathode can be controlled, and thus the brightness of the spot on the screen can be varied. Focus. Next, focus. Okay, 1 minute. Focus. Next, focus. Okay, next, focus. The beam of electron from the grid, passes through a series of electrodes, known as the first, second, and the third anode. First anode, second anode, and third anode A1, A2, and A3, all of which are at positive potential, with respect to the cathode. These electrodes act like an electron lens system and bring about a sharp focusing of the electron beam on the fluorescent screen. Generally the anode A1 and A3 are connected together and have the highest positive potential with respect to the cathode. Okay? While the anode A2 has a potential lower than of A1. A2 has a potential lower than of A1 and A3, but higher than that of cathode. The potential of the anode A2 can be varied, and thus the spot of light brought to a fine focus on the screen. Okay? The whole system consisting of the cathode, the grid, and the anode. The grid and the anode shoots. Shoots out a fine pencil of fast moving electron and is therefore called an electron gun. Okay? Electron gun. Deflecting of electron beam. 1 minute. Deflecting of electron beam. Deflecting of electron beam. Deflecting of electron beam. Okay? Deflecting of electron beam. 1 minute. Deflecting of electron beam. The common form of cathode ray tube uses electrostatic deflecting arrangement. For this purpose, two sets of plates X1, X2 and Y1, Y2 are mounted between the final anode A3 and the screen. And the plates Y1, Y2 are horizontal. Okay? The plates Y1, Y2 are horizontal and represent a parallel plate capacitor. In which an electron field in the vertical Y direction is set up. When a potential difference is applied to the plates, thereby causing the electron beam to move up or down. According to polarity of the plates. The plates X1 and X2 are vertical. And an electron field in the horizontal X direction is set up. And when the potential difference is applied to these plates, causing the electron beam to move from left to right, okay, or right to left, according to the polarity of the plates. Okay. If electric fields are simultaneously set up between the vertical and the horizontal deflected plates, the resultant displacement of the electron will be in accordance with the vector sum of the vertical and horizontal displacements. Okay. The position of the spot on screen can be therefore be adjusting by applying suitable DC potential to each of the two set of deflecting plates. Okay, one plate each pair x1 y1, one plate each pair x1 y1 is connected to the anode A3, so that there is no electric field between the plates, and the electron gun and the anode A3 is earthed. Electron gun and anode A3 is earthed. Okay, screen. Next, again screen. Okay, what is screen? What is the screen of a C.R.O, cathode ray, C.R.T, cathode ray tube? Okay, the screen is coated with a fluorescent material such as zinc orthosilicate, okay. The screen is coated with a fluorescent material such as zinc orthosilicate known as phosphor, okay, and brilliant spot is visible on the screen due to fluorescence where the electron beam strikes. The inside of the neck of the tube is coated with aquadag or some other conducting material, thereby connecting the screen to the final plates A3. The screen is therefore maintained at the same potential as A3, which keeps the electron beam from A3. The screen is therefore maintained at the same potential A3, which keeps the electron beam from A3 to the screen in free flight, as the space through which the electron beam passes is free from all electrostatic or magnetic fields except those set up between the deflecting plates. Okay, as the electron strikes the screen, these leak off to the anode A3 and finally through the power supply to the cathode. Okay, aquadag coating is necessary to remove the electron striking. Aquadag coating is necessary to remove the electron striking the fluorescent screen and return the same to the cathode. If the electron striking the fluorescent screen are not removed from it, these will repel the electrons. Which arrive on the screen, and the stage will soon come when negative charge on the screen will become so large that no more electrons will be able to reach the screen. Okay? The aquadag is not directly connected to the screen. It only collects the secondary electrons emitted by the screen when the electron beam strikes on it and return them to the cathode. Okay? While most suitable coating material. Next, willemite, most suitable coating material. Okay, willemite. Next, willemite. This is the most suitable coating material. coating material. Okay. In the selection of fluorescent material for a C.R.T. screen, cathode ray tube screen, an important point to be noted is persistence. Important point. Persistence. Okay. Persistence of its glow after the electrons have ceased to bombard. The screen. The most suitable material for this purpose is one which has a persistence less than 0.1 second. Okay, persistence less than 0.1 second. This is highly essential for rapidly changing images such as those displayed on a TV screen, because persistence of vision of the human eye is of the order. While met zinc silicate, ZnSiO4, zinc silicate, which fluoresces with green color is one of the material. Green color is one of the materials which satisfies this condition and is thus most suitable as coating material for C.R.T. screen. Okay. Second, time period. Second, time period. Okay. One of the great advantages of a cathode ray oscilloscope is its ability to indicate very short time intervals and to record various of voltage with time. If an alternating potential difference is applied to the plates Y1, Y1, Y2, the spot on the screen will trace out a vertical line. Okay, 1 minute. This is voltage. This is voltage 0, x-axis, y-axis, and this is firing voltage. Charging, discharging. This is charging. This is discharging. This is charging. This is discharging. This is firing voltage and extinction voltage. This is extinction voltage. Okay. This is time. Okay. If an alternating potential difference is applied to the plates Y1, Y2, The spot on the screen will trace out a vertical line, trace out a vertical line, trace out a vertical line, okay, proportional to the peak value of the applied voltage, proportional to the peak value of the applied voltage. If the waveform of the alternating voltage is to be obtained, the spot must be made to move horizontal along the x-axis, horizontal along the x direction, as well as move up down along the y-axis, so that the pattern may spread out on the screen. This is done by connecting the horizontal deflecting plates X1, horizontal deflecting plate X1, X2 to a source of voltage that rises gradually, at a constant rate of a maximum value, and then suddenly drops back to zero. Such a voltage is said to have a sawtooth shape. Such a voltage said to have sawtooth voltage, sawtooth shape, as you can show this figure, okay. It causes the beam to move horizontal. It causes the beam to move horizontally across the screen at a uniform speed, and then snaps or sweeps back to its straight line. The electronic circuit producing the sawtooth voltage is called sweep circuit. Sawtooth voltage is called sweep circuit. Sweep circuit, okay. Sweep circuit or time-based circuit, okay. The name time-based is due to the fact that when a sawtooth wave is applied to the horizontal deflection plates, the x-axis on the screen may be taken to represent time. Or time base is said to be linear if it produces a uniform movement of the spot. The sweep circuit or time base enables us to obtain a pattern on the screen which is exactly the same as a curve of varying voltage applied across the vertical deflecting plates, okay. Y1, Y2 as function of time. The only condition that has to be fulfilled is that the period of the sawtooth voltage must be equal to or an exact multiple of the period of the applied voltage to the student, okay. When flyback time is comparable to sweep time. When flyback time is comparable to sweep time. 1 minute. When flyback time is comparable, when flyback time is comparable to sweep time, okay. 1 minute. When flyback time is comparable to sweep time, an ideal time-based voltage is the one which has the sawtooth wave shape. You can show the figure number next. I will draw the figure, okay. You wait 1 second. Just 1 minute. And this is the 1 minute. This is voltage, this is y-axis, and this is x-axis, and the figure as like this, okay. And this is voltage, this is y-axis, and this is x-axis, and the figure like Okay. This is time t 0. This is flyback or retrace time. Flyback. However, in practice, the time-based journal in C.R.O. produces the waveform shown in figure of this. Okay, it takes some time for voltage to fall from the maximum to zero value. This time is intervals is called flyback or retrace. Flyback or retrace. Flyback or retrace. Okay, flyback or retrace time. When the time base voltage has a finite flyback time comparable to sweep the time, the display of the waveform gets distorted and a portion of the wave from corresponding to the flyback time is cut off as shown in the figure in this. Okay, and the path retraced by the spot during the flyback time is called retrace time. This retrace path spoil a good visual effect. To remove this effect in most of the C.R.Os, the electron beam is blanked off by applying a negative voltage to the control grid during the flyback period. Okay, during the flyback period. Next, synchronization. Next, synchronization. One minute. Synchronization. Okay, when two events occur simultaneously, they are said to be synchronized. The input signal applied to the Y plate is synchronized with the sweep signal and will appear stationary when the beginning of a pulse of the signal wave train is caused to appear at the beginning of the sweep trace. To keep the trace steady, a portion of the incoming signal is fed to the sawtooth generator. This serves to lock the generator in step with a vertical input frequency. In such a case, the trace is repeated again and again in the same position and thus appears stationary on the screen. Okay. Fourth, power supply. This is fourth, power supply. The power supply provides the high voltage for the cathode ray tube filament, voltage for vacuum tubes, if any, and low voltage for other valves or transistors in the circuit. And you can show the next point figure. Okay, and next is amplifier. Next is amplifier. To amplify the weak signal so as to increase the deflection in the vertical and horizontal direction without distortion of the incoming signal, the X and Y plates producing the vertical and horizontal deflection are connected to suitable amplifiers. Okay. Next, working of a C.R.O. Okay. C.R.O. Working of C.R.O. Working of C.R.O. Okay. We shall describe the working of a cathode ray oscilloscope by giving a method of finding out the waveform of an unknown alternating voltage. The unknown alternating voltage is applied to the Y plates. Okay. We shall describe the working of a cathode ray oscilloscope by giving a method of finding out the waveform of an unknown alternating voltage. The unknown alternating voltage is applied to the Y plates. The spark of the light will move vertically up and down, okay? In a vertical line is a response to the voltage applied and will simply trace out a straight line on the screen. When the time-based voltage is applied to the x-axis, X plate, it makes the spark move in a horizontal direction, and as the spark reaches the end of the screen, it is again made to fly back to the starting point, since the electron beam is now free to move in two perpendicular directions. Actual pictures of the waveform will be found on the screen. A stationary picture is obtained when the time period or frequency of the time-based voltage is adjusted equal to the time period or frequency of the unknown voltage. Okay. Application and usage of C.R.O. Application and usage of C.R.O. Okay. 1 minute. Application and usage of C.R.O. First, the chief use of a cathode ray oscilloscope is to demonstrate visually the variation in alternating or fluctuating current or potentials in electric circuit. The electron beam possesses practically no inertia and immediately responds to any variations. Okay. The chief use of a C.R.O. is to demonstrate visually the variation in alternating of or fluctuating currents or fluctuating current or potentials in electric circuits, or potentials in electric circuit, potential in electric circuits. Okay, electric circuits. The electron beam passes practically no inertia, and immediately responds to any variations, any variations, okay? Second point. It is used to measure the phase angle. It is used to measure the phase angle. It is used to measure the phase angle, power factor, phase angle, power factor, frequency, or alternating current, inductance and dielectric loss, inductance and dielectric loss, etc. Okay. Third point. It is used to trace the hysteresis loop of iron. It is used to trace the hysteresis loop of iron. Trace the hysteresis loop of iron. Hysteresis loop of iron. Okay. Fourth point. Fourth point. 1 minute. Fourth point. It is used in radio engineering to test the fidelity of response and depth of modulation in a wireless sets. Okay? It is used in radio engineering. It is used in radio engineering. It is used in radio engineering to test the fidelity. Test the fidelity of response and depth of modulation and depth of modulation in wireless sets. To study dynamic valve characteristics. Dynamic valve characteristics, observations on atmospherics, direction finding and detection of the reflected detection of reflected wireless waves as in the case of radar. Okay. To study the dynamic valve characteristics, observation and atmospheric direction, finding and detection of reflected wireless waves as in the case of radar. Okay, fifth point. Fifth. It is used in television receivers. It is used in television receivers, okay, receivers. Sixth point. It is used in industry for the study of mechanical pressure. It is used in industry. It is used in industry for the study. It is used in industry for the study of mechanical pressure. Study of mechanical pressure. Okay. It is used in industry for the study of mechanical pressure. Indicator diagram of internal indicator diagram of internal combustion engines. Electrocardiography is that study of the action of the heart. Study of the action of the heart, etc. as a display device. It is used in industries for the study of mechanical pressure, indicator diagram of internal combustion engine, electrocardiography, and study of the action of the heart. It is as a display device. Okay. Next, electrostatics deflection sensitivity.